Hi, welcome to part 4, I guess, of the video review. Question 14 is about a retail outlet that sells calculators. It's one of your standard carrying and reorder cost problems. So the question is, how many times per year should the store order calculators, and in what lot size? So I'm going to start there. I'm going to let S be the number of shipments per year. And C equals calculators per shipment. So right away, if I have 800 calculators total, then I know C is equal to 800 divided by S. Okay, now let's figure out my costs. I have two kinds. I have reorder costs. So for every order, I pay $1.75. No, sorry. For every order, I pay $8 plus $1.75 times C, because that's the number of calculators in that order. And altogether, that's times S. So I can write that as 8 plus 800 over S times 1.75 times S. And that's getting me 8S plus 800 times 1.75, which is whoa. Sorry, technical difficulties here. $1,400. Okay, and then my other costs are my carrying costs. So that is, it's $2 to store a calculator for a year. And how many I have one time is how many I have in a shipment divided by 2 on average. I order a shipment. Over the time period, I sell them approximately evenly, and that's how I get that. So in this case, my carrying costs just end up being C, which, as we know, is 800 divided by S. So my total cost is the sum of those two things. So 8S plus 1,400 plus 800 divided by S. And that's the thing I'm looking to minimize. I guess I can call that a capital C. So taking the derivative, C prime of S, I get 8, the 1,400 goes away, and then I get minus 800 over S squared. Setting that equal to 0, 8 minus 800 over S squared equals 0. I get 8 equals 800 over S squared. Multiplying both sides by S squared gives me 8S squared equals 800. That gives me S squared equals 100, which gives me S equals 10. Now I have to make sure this is a minimum and not a maximum somehow. That would make my problem a little bit messed up. So we'll do it like this. S double prime, C double prime of S. The 8 is going to go away. I'm looking up here. The 8 is going to go away. I have 1,600 over S cubed. This is clearly positive as long as s is positive. That means the function is concave up. So at 10, whatever, that is a minimum. This tells me we should have 10 shipments of 80 calculators each. The main thing I want from these sentences is I don't want them to contain any variables, because if you're asked a question at work about what your company should do, you're not working with variables, right? You're not going to come back to your boss and say C equals 10 or whatever, S equals 10. You're going to say, let's order 10 times a year. Okay, next page. The amount of money that customers deposit in a bank savings account is directly proportional to the interest rate that the bank pays on the money. This directly proportional to is important. Okay, let's let D be the amount deposited. P can be our profit. R can be our rate paid to depositors. Okay, so what we're saying here, it says up here, D is directly proportional to R. That means D is equal to KR for some constant K. And we don't know what that is. So you might think that the actual value of this constant is going to be important for this problem, and we'll have to see at the end if it is. If it is, then we can't solve it. Okay, so my profit is like this, right? Well, let me look at it like this. Here's the amount I'm going to pay out to my depositors. It's D, the amount deposited, times the rate. And the amount earned is 12% times the amount deposited, but I'm only loaning out 90% of the money, so it's 0.9. So that turns out to be 0.108 D. Now I've already got D in terms of my rate, so I'm going to rewrite both of these functions. Let me get a different color. This is KR times R, which is KR squared. And this is 0.108 times KR. Okay, so now my profit, P, is the amount I earned minus the amount I paid out. So that is 0.108 KR minus KR squared. Remember, K is that thing we don't know, that constant. Alright, so I want to maximize this, so I'm going to take a derivative. P prime of R is 0.108K minus 2KR. When I set this equal to 0 to get my critical points, Then I start solving this. 0.108k is equal to 2kr. I get r is 0.108k divided by 2k, and the k's cancel. This is why, weirdly, it doesn't matter what k is in this problem. And that gives me r is equal to 0.054. Now we look back at the profit function. It has a minus r squared, so it's a parabola pointing downwards. So this is in fact a maximum. So let's write our sentence. To maximize profit, the bank should offer 5.4% interest. Okay. Next problem. Implicit differentiation. So here I go. I'm going to write my formula. Y squared minus x cubed equals 41. Then I'm going to apply dy dx to both sides. Sorry, d dx to both sides. I won't take off points if you do this. It's just a little bit wrong. Okay. d over dx of y squared. We take the derivative of y just like we were going to. Then we multiply by dy dx because y is not x. Minus is for this minus here. Then d over dx of x cubed. That's just 3x squared. On the other side, d over dx of 41. That's just a constant, so it's 0. So now I'm trying to solve this equation for this dy dx right here. So I have 2y dy dx is equal to 3x squared. That's just adding 3x squared to both sides. And then I'm going to divide both sides by 2y to get dy dx equals 3x squared over 2y. So that's the first part of my answer. Then to plug in 2, 7, this line means evaluated at, so 2, negative 7. I'm going to take the x, which is 2, and plug it in here. And the y, which is negative 7, and plug it in here. And that's going to give me 12. Well, that should be negative 7, not 17. 12 over negative 14, which is negative 6/7.